So that's what this is, the standard form. It just combines all three of those. So let's use this page to summarize what all this means. So our A value tells us a couple of things. That number in front told us if the graph opens up or opens down. We call that a reflection. So reflection if A is negative. So if our A value is negative, we say that there is a reflection. This also tells us if there's a shrink or stretch. You remember how it got really skinny? So it got stretched out, and then it got fatter, so it shrunk a little bit. So A also tells us shrink, or if A is negative, less than 1, it's less than 1, or a stretch if A is greater than 1. And I'm talking about the actual number, not like -3 would be a reflection and would also be a stretch because 3 is greater than 1. And this also told us the slope. So slope of each line. So that A value tells us a lot. Now the H tells us left or right translation. You know, we talked about translations in geometry. So instead of saying the word shifting, let's say translation. Okay, if it was, again, x minus a number, it went right. If it was x plus a number, the translation went left. And then for k, that was an up or down translation, where if it was positive, it went up, negative, the translation went down. So we're going to combine all of this now. We're going to use what we talked about earlier to graph some absolute value equations. So we have y equals the absolute value of x plus 3 minus 2. Compare the graph with the graph of y equals absolute value of x. So we're going to look at this function and tell if there's a reflection or not, a shrink or stretch, and a translation. So we do what I call RST. R is for reflection. There's no negative sign out in front, so that means there is no reflection. There's no number out in front, so that means there's no shrink or stretch. And translation. This is x plus 3 inside the absolute value bars, so that means we are translated left 3. And because we have minus 2 on the outside, it is down 2. So that's where our vertex is going to be. Our vertex is going to be at -3, 2. Right here. Now, what we do is we look at our slope, or the number in front. The number in front is that invisible 1. So our A value is 1. That means from our vertex, we're going to go up 1 and right 1, up 1 and right 1, and keep going. And then back from our vertex, we can go up 1 and left 1. And when we connect these dots, that's how we get a V shape. Domain. The domain for absolute value functions is always -infinity, infinity. Always. Absolute value functions always have a domain of -infinity, infinity. Now the range, this function is opening up, so that means it has a minimum value. So we look right here at our vertex, and we look at the y-coordinate. It's negative 2. Sorry, the vertex here should be negative 2. So our vertex is negative 2, so that is our smallest y value. And we go all the way to infinity because our function is opening up. Now the end behavior. Remember, for end behavior, we're going to have a left side and a right side always. So as x approaches negative infinity, that means left side. And as x approaches positive infinity, that means right side. So the left side is going up. Is going up. So we say y approaches infinity. And the right side is also going up. So in an absolute value function, the ends will do the same thing. Because if we look at a v, that's what an absolute value function is. If the graph is a v, the v is either pointing up or the v points down. So the ends will go in the same direction. Let's look at this example. We're going to do the same thing. R, S, T. Reflection, we have a negative in front. So yes, there is reflection. We'll write reflection over the x-axis. The reflection will always be over the x-axis for what we're doing here. I'm just writing it because in case you see it somewhere else in a different class, you'll know that it's a reflection over the x-axis. Our a value is negative. Now shrink or stretch, because it's a 2 in front, it is a vertical stretch by 2. And our translation, it's -1 on the inside, so we're going to move right 1. There's no number on the outside, so we're not moving up or down or anything like that. So our vertex will be 1, 0. And our a value is -2. So from our vertex, we're going to go down 2 and right 1. And for our vertex, we're going to go down 2 and left 1. So our absolute value will look like this. This is what a graph will look like. Remember that a value is your slope. Domain, negative infinity, comma, infinity. Range. Now, because this absolute value function is opening down, the smallest y value we have is negative infinity. And then we use the y coordinate of the vertex as our biggest y value. Because if we look at our graph, the highest y value we have right here is 0. And then the end behavior, as x approaches negative infinity, that means left side. And as x approaches positive infinity, that means right side. Both sides of this absolute value function are going down. The arrows are pointing downwards. So y approaches negative infinity on both sides. Let's look at the next page. So again, same thing. We have y equals 1/3 absolute value of x plus 2. So r, s, t. There is no reflection. There is no -9 or negative sign out in front. So no reflection. Then shrink or stretch. This is a 1/3. So it's a vertical shrink by 1/3. And the translation, since this 2 is outside the absolute value at the very end, we are translated up 2. So that means our vertex is 0, 2. And our a value is 1/3. So that means from our vertex, we go up 1 and right 3. Up 1 and right 3. Then from our vertex we go up 1 and left 3. Up 1 and left 3. So this V is shrunk. All right, domain, negative infinity, comma, infinity. Range is going to be positive 2, comma, infinity. Because our absolute value graph is opened up, we want to make our y-coordinate of the vertex the smallest value, so that's why that comes first. And then for end behavior, as x approaches negative infinity and as x approaches positive infinity, the left and right side are doing the same thing. They're both going up. All right, the last one will combine a bit of everything. So it's y equals the negative 1/4 absolute value of x plus 1 minus 2. So this has everything in it. So RST. Reflection, yes. Reflection over the x-axis. Because our a value is negative. Shrink or stretch, there's a vertical shrink by 1/4, because that is our a value. In translation, we are translated left 1, because it says plus 1 on the inside. When the plus or minus is on the inside of the absolute value, it's the opposite direction of what the sign shows. But when the number's on the outside, like this negative 2, that means you're going down 2. You do what that sign says. So this means our vertex is at negative 1, comma, negative 2. So here's our vertex. The a value is negative 1/4. So that means from our vertex, we're going to go down 1 and right 4. And for our vertex, we're going to go down 1 and left 4. So that's a very shrunken down absolute value graph. Domain. Even if you don't get all of these parts, when you're taking a test or a quiz or an assignment, the domain for this absolute value you should get no problem. Always negative infinity, comma, infinity. Range. Because our graph is opening down, the smallest y value will be negative infinity, and the largest y value will be the y-coordinate of our vertex, which is negative 2. So then our end behavior so we have x as x approaches negative infinity and as x approaches positive infinity. Both ends of this are going down. Our arrows are going downwards. So y approaches negative infinity, y approaches negative infinity. So I hope that this video was useful in how to graph these absolute value functions. We didn't use a calculator, we didn't use a table. We plotted the point and then counted using our slope. So I hope this makes sense. Make sure you like the video and subscribe.